Hi everybody, and welcome back to this kind of lecture, second video in this lecture, where we're talking about the SCR calculation. So in the previous video we talked about this at a high level in terms of you can either use a standard formula or an internal model to calculate the SCR for your company, and it's up to you which of those you choose to try and do, and there are pros and cons of both of them. Standard formula is quicker and easier, but arguably less accurate. And if you build an internal model and get an internal model approved, then maybe the SCR calculation that you get will give a smaller SCR number than the standard formula, so you end up with more capital or more free assets available, which is attractive. But an internal model is a lot more work, so you need to kind of decide what it is that you want to do. What I'll do in this section is concentrate just on the standard formula approach, so you can get a little bit of a sense of how it works. So this section is called Standard Formula. Okay. So the standard formula approach is to work out the 99.5% value at risk of, so it's kind of the 99.5 percentage point of the distribution for this formula. So value at risk of, let's stay in black, MV of A at t equals 1 minus BEL at t equals 1 minus MV of A at t equals 0 minus BE of L at t equals 0. So this whole thing. So you might notice that the risk margin is not in this calculation, and that's to stop the whole thing getting circular and problematic, because the risk margin is a function of the SCR, and what we're trying to do is work out an SCR here. If you didn't have a BEL and a risk margin, then you could replace this with market value of liabilities. But this is the formula that's mostly being applied. So standard formula approach is to work out the 99.5% value at risk of this, and well, in fact, let's work out the 99.5% value at risk of this, let's say, just changing my notes, how should I write this? Standard formula approach is to work out let's delete this. Delete this. to work out this and take the 99.5% point of this distribution for each risk separately and then combine them together. Okay, I think that's fair enough. Okay, new bullet. The 99.5% shock for each risk is given in the regulations. So you don't actually need to worry about the distribution of this under treating everything as a random variable in some sense. You are being given the 99.5% shocks. So examples will hopefully make this much clearer. So 99.5% shock for each risk is given in the regulations. So for example, in a simple case of equities falling in stable market conditions, the 99.5% shock is a 39% fall in equity values. So for instance, if you were doing your own internal model and you had a distribution and you find the 99.5% point for change in equities, you might find that it's a 39% fall in those equity values. The standard formula just gives you this final answer, so you kind of don't need to worry about the 99.5% bit. Similarly, we could come up with another example. So, e.g., for longevity risk, the 99.5% shock is a 20% decrease in all mortality rates. So again, you don't need to worry about the 99.5% number. You're given this 20% number, and that's the number that you use. So if we go up to this first one, the 39.9% fall in equity values, and you look at this formula, Well, you've got a market value of assets at time equals 0, best estimate liabilities at time equals 0. So this is taken from the market. This is your initial calculation. And then this bit here is what you apply the shock to. So the 39% fall would go into this market value of assets, and the best estimate liabilities wouldn't change. So that means that this would cancel with this, and so you just have the effect of this thing minus this thing. And that will give you a number, a negative number in this case, which you would then, well, depending on how you're applying it, might flip the sign. But essentially, you're getting the impact of the significant equity shock on your balance sheet. Similarly, suppose we're thinking about just this piece. What's the 99.5% shock for longevity risk? Well, it's a 20% decrease in mortality rates. So again, you've got your market value of assets at time 0 and your best estimate liabilities at time 0. You haven't done anything yet. And then you apply the shock over here to time 1. So longevity risk is unlikely to affect the assets at all, so this thing stays the same. But your best estimate liabilities are likely to get bigger as a result of the 20% longevity shock. So this number here changes. So this one here cancels this one here probably, and then this thing here, when we sort out all the negatives, becomes positive, and you're subtracting off this thing which is bigger, so again you get a negative number. So for all of the different shocks that you can have, equities is a risk, so there's a shock. Longevity is a risk, so there's a shock. Mortality is a risk, so there's a shock. Interest rates is a risk, so there's a shock. For all of these different things, you work out a separate number which is a result of this kind of whole formula. So you end up with lots and lots and lots and lots of separate numbers. We haven't worked out the SCR yet. In some sense, we're just working out the contribution to the SCR from each of the different risks, and then we then have to kind of stick them all together. So let's continue. Let's switch back to black. So once we have all these separate SCR contributions, then we combine them together via correlation formulae. So again, this is just another part of what's written down in the regulations. You're told exactly what you're supposed to do. So for instance, the regulations might tell you to work out a contribution to the SCR from market risk. And it'll do it, or make you do it, by following this kind of formula. So you take the SCR for equity risk and you square it. So this would be the result of this formula up here for the 39% fall in equity values that we've been told to use here. So that gives you some kind of number. That's your SCR of equity risk. So we square that, and then we might add the SCR squared for interest rate risk, and then add on 1 times the SCR for equity risk times the SCR for interest rate risk plus various different components for other risks. So for instance, you might have property risk. So you'd have an SCR squared for property risk, and then you might have one of these kind of terms here, which is some number times the SCR for equity risk times property risk, and then the SCR for interest rate risk times the SCR for property risk, and so on and so forth. And the whole formula, however big it is, then gets square rooted. And this number 1 here, for equities and interest rates, this represents %50 correlation. Let's put in brackets. Example. So if the regulator thinks that the two risks are correlated in different ways, so for instance if they thought that they were 100% correlated, then this would be a number 2 here. If they think that they're not correlated at all, then this would be a 0 here. So the regulator gives you the formula, but also gives you the numbers for these correlations, which is why these kinds of formulae are called correlation formulae. Again, everything is all written down in the regulations. So you work out from all of your separate numbers that you worked out based on all of the different shocks. For all your separate numbers, you then combine loads of them together using these kinds of correlation formula to give you a smaller set of numbers. And then, let's get ourselves more space. All these separate components are combined. I'm going to say like a tree. So, for instance, you're trying to get your final SCR, and that might have contributions from market risk, or if you like, the SCR for market risk, which we calculated in that previous correlation formula. And what's going to go into here is the SCR for equity risk. So that's a number that goes into the formula for calculating this SCR market risk thing. Similarly, we're going to have an SCR for interest rate risk. Other things that might go in here are SCR for property, for instance, or SCR for credit spread. And then there'll be other things other risks that will contribute to the SCR. So, for instance, SCR for life risk or life insurance risk, or SCR for operational risk. In terms of life risk, what kinds of things could go into here? Well, SCR for mortality, or SCR for longevity. I'll put just another couple in, SCR for lapses and SCR for expenses. And so, for instance, to combine all of these things together to go into market risk, a formula is used. And again, you are given the formula. Similarly here, to put all these kind of final results into the SCR, a formula is used. In order to put all of these separate results into the SCR for life risk, let's see if I can squeeze in some green here. So again, a formula is used. Everything is written down. Every shock for each of these separate components is written down. All the correlation formulae, the green bits that get used to kind of go further up the tree or down toward the base of the tree, are given to you, and you just do all the calculations. And finally, everything is combined. The final kind of or penultimate results are combined up here to give you a final result for your SCR. Okay, let's break here, I think, and then when we come back, we'll just talk briefly about what the problems are with this kind of standard formula approach. So I'll just put in some red dashes, signify that we'll switch to the final video next.